thank you for being here and the people online who are watching. I appreciate you giving me the opportunity to talk AppSec and talk about just how we can be effective or not. I'm probably going to kick some elephants in the room so that they make some noise. I hope. Um, you know, something I'm not going to talk about is hacking. I'm very sorry. So I know that Black Hat and DEF CON are generally devoted to security research, which is critically important. Don't get me wrong, please. Or hacking, if you prefer to be calling a hacker. I was going to take hands here, but I don't think I have time. But for all the folks who are on the online and in the room, if you're a developer, for all of the rest of us who are in the security industry, these are our most important people. And I hope that I'll make that clear by the time I finish this talk. So thank you very much for being with me. And I want you to remember one number, 28 million. 28 million. I have not looked at their research, but Evans Data estimates there are 28 million programmers, developers on planet Earth right now. Now, it doesn't really matter to me whether it's 32 million or 20 million. The fact that it's tens of millions is very important. So if it's 28 million or 29 million or 25 million, it's not really important. But the fact that there are tens of millions is very important. And here's why. This is an old book now, 2012. We're well down this path, well down. We're here, trillions. And those 28 million programmers, they're adding to our pile of software, which is a pile of weakness and vulnerability every second of every single day. Piles and piles and piles. So maybe that doesn't matter to you, but it matters to me because I don't have any money. I have ones and zeros. I want there to be inventory at the grocery store, and they manage that with ones and zeros. My car probably has 200 processors in it, lots of ones and zeros. So it matters. It matters in very real ways. And we're well down this rabbit hole. 28 million programmers, trillions of devices. How many devices do you have on you right now? Couple? Couple, 3, 9? Think about your smart TV. It's a Linux box. Yeah. So is your headset, by the way. So, we have some problems. And I don't mean to be offensive. I know, Can We Fix AppSec was intended to be controversial a little bit. But I don't mean to offend anybody, but I probably am going to offend almost everybody unintentionally. I'll apologize now. Myth number 1. I've heard this for years. If only they would pen test all their code. Think about the economics of that. Anybody here a pen tester? Yeah, you make your living pen testing? Well, what is your consultancy? Maybe you can charge this yourself. Probably charges $200, $250 an hour. Maybe you're one of the great ones who charges $350 or something like that. And then think about that spread across 28 million programmers. Basically, if you pen tested every bit of code that went out, what would happen? 90% or 80% of the software businesses would be out of business. Pretty much. So it's not really practical. And there aren't that many great pen testers anyway to stretch. So when we say it's someone's fault, or if only those programmers could code securely. Anybody heard that one? I've heard that for the last 20 years. If only those programmers would code securely. Yeah, but we'd have to train them. They'd have to remember. They have to have tools. I mean, I've written hundreds of thousands of lines of commercial code. And maybe your code is mistake-free, but mine never was. And so, it's my code writing has humbled me pretty heavily. So, is it someone's fault? Well, let's get to some basic computer science, okay? The foundation upon which we're living. Oh, not this guy. That's not Alan Turing. That's an actor. This guy. And by the way, he didn't break Enigma. Polish programmers had been breaking Enigma since 1929. And if it weren't for those Polish cryptographers, we probably wouldn't have won World War II. Just to be clear, he did do some really cool things, but we're not going to here to talk about those. If you want to talk about those, ask me in the hall what the bomb really did. It's basically a search for a key, what we call a key today, settings, but a key with a known plain text. Very important in computer science, but he didn't break Enigma. But he did write a proof in the mid-1930s, a mathematical proof that says an automated process cannot prove that an automated process is implemented correctly. And I want to be clear about the word implemented, because you can have formal proofs about which algorithms are better than other algorithms. That's not what I'm talking about. I'm talking about, can you prove that software is correct? Can you prove the software is correct? No, you cannot. It's an unsolvable problem because it approaches infinity. All right, that's the ground on which we stand. Then you add in Turing, another Alan Turing piece, Turing complete languages. And that means there are a near infinite ways to express something. So security vendors who have security tools, a near infinite way to express things, it's kind of a problem. And if you add these two things together, the ground on which we live is that you can prove software has bugs, but you can't prove it doesn't. Think about that. You can prove software has bugs, but you can't prove it doesn't. That's the ground on which we live, extra Dijkstra. 1969, things haven't changed. There will be bugs. So don't get rid of any of your incident response teams anytime soon, because you're going to need them. Of course, not all coding errors are security bugs. We know that. And it's sort of obvious. Not every weakness is a coding error, just to be clear. But I'm not going to talk about the secure design parts because this is FuzzCon. Ask me in the halls again about that. It's something I've talked about. All right, so there's going to be bugs. That's the ground on which we live. Next myth, that we can fix them all. Anybody ever heard that? In fact, one of my favorite people on whose shoulders I stand, we had a little public argument about fix them all, and he was saying, no, they should fix them all. What do you do when you have a queue of 130,000 vulnerabilities? I don't make these numbers up, by the way. Every number I give you is a number that I know is real, okay? Such as we can know it. So that's not a made-up number. 130,000 or 30,000. How many do you think the ops people actually fixed? Yeah, what they said was, go talk to my VP. That's not on our list for this year. That's what they actually said. Trying to fix them all. We know in that pile, intuitively, that there's serious risk. What we don't know is which ones are important and which ones we can ignore. That's actually a very difficult problem. I'll get to that. So we live in this world where we can't fix everything because we don't have enough person power. And right along with that, we know there's going to be bugs, some of which will offer attacker leverage. That's our world. Get used to it. It's not changing anytime soon. And I just love this quote from Adam Shostak, who's a friend of mine and probably one of the premier threat modelers on the planet. It's complex. It's a multivariate, multidimensional, multidiscipline, multi-domain problem. And when we come up with simplistic solutions to that, they are obviously going to be less effective. So, what do we do? Well, here's a myth I run into all the time. Um, James will remember this. My dear friend James Ransom, who's back there right now, he will remember this. A CTO who came and said, I pay for static analysis. Doesn't that take care of the problem? Yeah. Answer is no, because it's a multivariate, multidiscipline, multidimensional, blah, blah, blah problem. It's a complex problem. And so we can't do it. And yet, when I do security assessments, software security assessments for people. That's one of the ways I make my living, along with threat modeling or teaching threat modeling or teaching people how to be better security architects. Those are the ways I make my living. But one of the things that we have is a lot of times you find a company and the first thing they do is they're being asked to do pen tests, so they get a pen test going. That shows they have bugs, so they buy a static analyzer, and then that's supposed to drive sales, but they're still having problems. And that's because static analyzers, especially, and I do understand about IAST, but I'm just going to break it down this way. There's a study in 2011. 1 in 4, David said. Wow, that would be a really good number. That study in 2011 found about 85% false positives. And that number lines up very well with my friend Ryan Ware, who ran every major static analyzer at Intel on their Linux kernel. So, it can vary from 75% to 15% fidelity. Yeah, it can be really bad. So, eccentric findings, they don't always match up, is what they found. So different tools find different things. Then there's the price problem. And security tool vendors, how many of those 28 million do you think can afford a $50,000 server? I'm not making that number up. That is the cost of a server for a particular static analyzer, if you want one. I'm not making, then there's a per user seat charge too. But that's what the cost. You can't even start unless you got $50,000. How many of those 28 million think have $50,000 for their, what do you think? 10 million? 3 million? 1 million? I don't know what the number is. I have no idea. But I'll bet you it's not 28 million. There's a variation problem, which I've complained about since I think on stages since about 2006 or 7. When they report every variation, great for security people, but developers want to know, where's the bug and what do I do about it? Just give me one finding, not 40 for the same bug. So I hear one of the major vendors has finally cured that, one of the major static analyzers. I'm not going to mention any products here. That's not my job. And by the way, I haven't been compensated for this talk. I'm under nobody's fault. These are my opinions. And then we sort of, there's some problems with terminology, what's a vulnerability scanner, and then idiosyncratic tests. As a pen tester, not to pick on you, but you raised your hand. So your ability to do your job is dependent upon your skill, the tool set you have, your understanding of the target, right? Your understanding of the target, and your emerging threat model of the target, what works and what doesn't. So pen tests are idiosyncratic. I'm not saying you shouldn't pen test, believe me. I'm not saying that. But I am saying that there's some problems. It's not a cure-all. So this is kind of a problem. There are some other myths and conceptions. I'm just going to go through these really quickly. Open source is not free. It's a contract with the future. We're trading development time now for security maintenance on into the future. CVSS does not equal risk. That's wrong. It's a severity rating, potential severity rating, and there's a lot of great research starting with Alati and Versace in 2014 and going right up to EPSS, exploit predictive scoring system in 2019, that you might check about that. Cloud does not take care of your security. It does some things for you. And I don't know what people think we can do as security people when they call us 2 days before go live and say, "Can you review and bless my?" Yeah, it doesn't work. Yeah, you're going to get reworked there. And just to touch on it, threat modeling is not the artifacts or the techniques we use. These are some other things. And if you want to talk about these, grab me in the hall. Basically, this is a quote I just read in Wired this a couple months ago, and I thought, it kind of sums things up. So, is there something we can do? That's the major question here, right? I don't want to be all doom and gloom and FUD, but I think we have to turn our heads around. I think we really have to turn our heads around and look at the problem in a different way. I like this quote. I don't know this person, Aaron Reinhardt, but I intend to read his book, Chaos Engineering, because it seems interesting. But nevertheless, it's kind of a chaotic environment. There's a lot of creativity and innovation that happens in coding, and we need to acknowledge that as security people and work with it rather than saying, no, I'm going to constrain you so much that you can't be creative anymore. That's a boring job. It's a factory job. Nobody wants it anyway. We have to kind of turn our heads around. And I ask myself this every day when I come to work. How am I enabling secure enough while also not getting in the way of creativity and innovation? I want to say I'm not talking about, this is not Threat Model Con and it's not SoftSet Con. I'm going to focus on verification. If you want to talk about these other things like secure design, I'm really passionate. I've written a bunch of books about it. Not that they're necessarily any good, but I have said a lot about it and I do care about it a lot. But I'm not going to talk about it here because I don't have time, frankly. But catch me in the hall, catch me out here with a glass of wine or whatever your beverage of choice is. And if you want to start with the Threat Modeling Manifesto. 14 amazing people got together and put their heads together. What do people need to know about threat modeling? And so we turned out that thing. This was a brilliant idea. My friend Isar, he's been on a whole bunch of these projects that I've worked with him on. And so he said this to me a couple of days ago on the phone. He said, wow, if you do a pen tester of your bug bounty hunter, you got to build a threat model. If we can't threat model, why can't we just pay people for the threat model they get, right? And I thought it was a cool thing, so I gave Isar a little shot here in my presentation. It's a cool idea, I think, and he has a new book about threat modeling out there, which I think is terrific. So what I want to talk about is what is our toolkit? Now, you might divide the territory up a little differently than I do. It doesn't really matter. I don't care. And I understand there are some combinatory techniques like I asked that's not up here. These are the basics. And it's a way of talking about this. So forgive me if I don't touch on your favorite tool or technique. This is our toolkit. This is our toolkit. And no, it's not even. It's not a PowerPoint smart art. It's very uneven. And the intersection is very small, unlike this graphic. But, this is what PowerPoint does. So we have code review. But the only way you can scale code review is with peer review. And then you have a junior programmer who puts their code in front of another junior programmer, and then a second junior programmer says, yeah, it looks just like mine, passed. Not a very good review. So there's some problems with scaling there. But it's a tool. And it's one of the first things people usually do. So, we have to make it work as best we can. There's static analysis. And as I said, there are all kinds of problems with that. But if we could get that on everybody's desk, even if it was a minimal set, so that as you're writing code, when you're working and you expect to make mistakes, you're getting feedback. Why? It's not only getting those bugs out of the code, but you're learning, because coding is a lot like learning an instrument. You have to practice. You learn a little bit, and then you practice it, and then you take the next bite, and you practice it. And so those 5-day trainings, not to knock anybody's business model, but those 5-day trainings, people don't retain a lot, but kind of a little bit. And static analysis on people's desks would be fantastic as they code, even if it's a really reduced set. because it's automatic training and it's automatic practice. Okay, negative testing, you can't imagine how many times I go to companies and they are not doing negative testing. They never put in the wrong API key and see what happens, or a funny API key. And if your API keys don't have a lot of entropy in them, they're guessable. And so, and I see that too. I see that too. Um, I'm not going to go into the scanning. You can scan HTTP stuff. That's really great. There's vulnerability scanning. And of course, there's pen testing. This is our toolkit. Pen testing is a great scalpel. It's like deep surgery. So we can't do all of our code because of that. And then there's fuzzing, of course, which is why we're here. What does fuzzing give us? Fuzzing gives us some stuff we can't get other places. For one thing, you can do any input, not just HTTP stuff with fuzzing. So that's very powerful because while you have vulnerability scanners for your HTTP inputs, how do you get the same kind of assurance against like your command line or that wonderful input screen that your desktop software uses? How do we get assurance with that? Fuzzing can give us that. It's the unknown unknown, which I love about fuzzing. It's the unknown unknown. They can find 0 days. And in a way, we don't really care if there's security because if your program misbehaves, you've got a bug. And fuzzing's really good at that. We don't really care if it's security because if you misbehave, the target misbehaves, or worse, crashes, you know you got a bug. And you know what did it? You can regress that really easily and just add it to your regressions. So fuzzing's been great. I've been requiring fuzzing for years. But unfortunately, oh, and I have to make one other point about fuzzing. Remember that your attackers are fuzzing your inputs. All those API keys that are protecting your API, well, if you have 30,000 customers, that's 30,000 people who are protecting that API key. How many of them do you think have security well enough to protect your API key? 29,000? Maybe. And then there's the problem of if you have two governments that hate each other and they're both using your product, you think they're not whacking your API to find out if they can get through it so they can get to their adversary? Highly unlikely. So your attackers are going to fuzz you. So why aren't you fuzzing? Well, there are reasons. Why isn't everyone fuzzing? Up until fairly recently, it's been very boutique. Very boutique. If I needed really good fuzzing, I had to hire a pen tester who could fuzz at $200, $300, $400 an hour. It's been difficult, obscure. I know there are open source tools. I know about American Fuzzy Lob. I do, believe me. I know about Wrestler, and those are some nice steps. But it's been hard, and I know this for a fact because I had 125 security architects, and when one of them wanted to learn about fuzzing, it would take them for 6 months to get up and running. 6 months. That's a long time for somebody who has another job or a related job. It's too long, generally. The fastest I ever saw was 3 months. I was one person. Yeah. It's been expensive. The tools have been $1 million tools. That's kind of a 28 million. That's kind of a stopping point right there. And some of those tools have had wrong targets. Like if you're writing business code or a business API, you really don't need to be fuzzing the protocol stack. You're using somebody else's protocol stack, and hopefully they fuzzed it, but that's not really your responsibility. So there have been some wrong targets, which have been painful for me personally in my programs. And sometimes people just do something ad hoc to try and get some assurance in this way and find the unknown unknowns. It's been very boutique until recently. I don't know this guy, but I like this. He's on a podcast. I liked what he said. I want fast, scalable, customizable, easily added, integral, to SDLCs. And by the way, I've been saying this for years. I wasn't compensated for this talk. This is something I've been saying for years from stages like this. So what would an ideal look like? Fuzzer or anything else? This is what I want in my tools. This is what I want. And this is what we should be demanding, that the tools be straightforward, not take 2 years to get configured. No, I'm not making that up. I got to one organization and they had one team had 72,000 static findings. Guess how many they fixed? Right. It's an overwhelming number. Or 46,000, that was the other really high team. They fixed none. Oh, we ran static analysis. Yeah, right. So, straightforward, natural in the way people build software today. That means DevOps. That means agile. That means iterative. Not something, that's from a bygone era where you're expecting it to be completely waterfall. Well, some people still produce software. I haven't actually run into that recently. But most people don't. Obvious automation. I shouldn't have to study your automation language for the next 6 months in order to get it automated as part of my build chain. Understandable and reliable results, which David was kind enough to speak to. Reliable. We need reliable results. Point me to the bug, if possible. And lastly, affordable. 28 million people adding to our pile of weakness. And if you think that that doesn't affect you, my API is connected to 3 other APIs, which are connected to 14 other APIs, when somewhere in that long chain of APIs all connected together is one written by the millions of programmers who are not working for an AppSec savvy company, who are not fuzzing their API. Yeah, affordable. This is what I want. This is what we need if we're going to really solve this problem, I think. And if you want to argue with me, please tell me I'm wrong. Tell me how I've gotten this wrong. So let me just sum up. There are common myths and faulty assumptions that are holding us back every single day. So if your company is using CVSS as its risk, I'm sorry, it's not working. That's how we got an Equifax bridge and a bunch of other ones too. And provably so. I've cited the research. There will be vulnerabilities. So don't get rid of your incident response team. We need lots of different techniques because the state of the art of software security tooling today, none of them is a panacea. We need lots of different techniques so we get all the coverage we need. Fuzzing is critical. How can we get it on everyone's desk for all of our APIs, at least, if not every input? And I've described what I think would be an ideal tool. Nobody's compensated me for this, so if there is a tool in the world that's really getting close to this, kudos. Thank you. Thank you for approaching this, because we desperately need it. We are not, this isn't a celebration of how successful we are, these conferences, right? So I hope that gives you some sense and gives you something to stand on and some realities, what I think are the realities of our world. If there are any questions, I'd be happy to take them.
You mentioned in the very beginning about the developer being the security's best friend. How does you've seen getting developers excited and about security when it may have not been their responsibility before?
Yeah, that's a great question, and I've been struggling, just as everyone in security has been, since 2001. I was Cisco InfoSec's very first application security architect. So I've been wrestling with this problem for a long time. And what I discovered, quite by accident, is that I need a tipping point. This is the most important thing, and the tipping point isn't a majority. I get on a team of, let's say, 10 people. If I get one person on that team who's just curious, it begins to shift. If I get 2 people, doesn't matter what their role are,
suddenly everybody goes, oh, security, it's important. So there's some cultural stuff there. The tipping point is not a majority. It's not even a minority. It can be one or two people, number one. Number two, we have to help developers understand that security isn't some special ility from the side. When I got into security, we were the special people. I literally had one person look at me when I was a newbie and say, we don't have to follow the rules, we're security. Now, personally, my integrity says if I'm asking somebody to do something, then I better be following those rules to the nth degree. Otherwise, how can I, in good conscience, ask them to do it? So there's some modeling there. But we were the special people, right? I want to change security from some special domain to, yeah, there's some special stuff we need to know, and especially in threat modeling, having a good understanding of the attacks and defenses is actually a specialty knowledge. There's specialty knowledge for exploitation for people who are pen testers and security researchers. That's really critical. That advances our engineering art. But in general, there's a lot of things that developers can do if they just have the tools and the understanding that it's important. And my experience is when you put it like that and you bring them into the conversation and you don't go bork everything they're doing by saying, no, I want to do it my way, you have to do it my way, but you say, how can we make this work and protect what you're doing that works for you? You get a really different answer. So I think, James, did we have 4,000 developers at our last gig together? 4,000. 5,000 developers, and the vast majority of them wanted to do security and took it seriously because we did it. Now, I'm going to say one other thing, and this is something that may not be obvious, but I learned quite by accident at that gig. If you get people to play at attacks and defenses, that is, you introduce them to threat modeling, they suddenly get the entire security development life cycle in a way that nothing else that I've found changes that culture and builds this culture of security. So it may not be their job, it may not be anything, but when you introduce everyone to threat modeling, somehow there's the practice of that helps people actually climb into it. So we started training everyone. I mean, in non-technical roles, project managers, line managers, product management, product owners in threat modeling. And suddenly, boom, people didn't always know what to do, and they often had disagreements about how to do it. But there was no argument about doing security. None anymore. So that's a little trick that I learned the hard way that I hand to you.
Brooke, I have some questions from our virtual audience. The first is, know of any one university course on fuzzing so that it is taught alongside numerous dev courses?
Oh, wouldn't that be the world I want to see? I'm sorry, questioner. I'm sorry. But as far as I know, well, maybe David has been doing that, or Jared at their work, which would be fantastic. But the universities I know, generally they have an exploit class, which not every computer scientist is required to take. My friend K-Map taught that for USC for years. So I know these have been out there, and they certainly teach it at the university where I'm going to start teaching in the fall. They certainly have a decent course in it. It's taught by somebody else. So there have been those courses, but that doesn't really get to the broader software security problem, I'm sorry to say. It kind of, again, it's kind of attacks, and in this case, fixes but not defenses. So it's a little bit different than what I was just saying a moment ago. So, I'm dying for some security architecture courses. I'm dying for some techniques, in verification that people learn right along with programming and their basic computer science and basic software design and some of those things. I'm not seeing it. Maybe one of these fine folks is seeing it, in which case, please trumpet it so other people start.
And sorry. Then we have one more. Oh, I'm sorry, are you done?
No, please.
Okay. So the second one is, how do you justify to the company the business cost in fuzz testing versus developing and rolling out a new money-making product or feature?
Yeah, there's the hard one. Because we don't live, unless you're working with a $60 billion black budget, I am not making that number up. That was in the news. Unless you're working with a $60 billion black budget, you may not get everything you want in security. So James and I fought strongly for fuzzing and fuzzing tools at our last gig together. And how long did it take us? 2 years? 2.5 years? We just fought. We just kept bringing up the bugs that would have been found and making the case. It was always part of our strategy. Always part of our strategy. But, first we had to say, we recommend that you fuzz, because they didn't have a tool. They didn't have any training. How can we say fuzz? I mean, we're asking them to do something they can't do. So you have to keep after it. And the one thing I have discovered in my career is don't give up. If you know something's the right thing to do, it took 8 years, yes, 8 years and 4 security architects to get Cisco to put their authentication, their web authentications into HTTPS. Now, that's a long time ago, so, this is old news. But 8 years. If we had given up in the second year, it might still, no, it wouldn't still be that way, of course not. But still, 8 years. And 4 security architects worked on it at various points, including myself. And the person who originally required it got the gig when they finally did it. And so he was able to, recoup the kudos and everything for the improvement. So I was really glad about that. But still, don't give up. If you know it's the right thing to do, just keep making the case. And the other thing is, you can get people, anybody who's interested, I never refuse any help, ever. I find a place for everyone. All God's fuzzers, verification people, security testers or coders or whatever got a place in my choir, I'll tell you. So let me just finish if I may. I will find a place, and if somebody wants to learn about fuzzing on their own, I do everything in my power to make it happen and give them a safe space to do it. And then I can use that as leverage to say, look what we found. Look how cool this is. Look how we're getting stuff out of our software. You want to get this stuff out of your software? And then you kind of build like that. So it's incremental. Just don't give up and keep using every leverage you can. I think that's probably all the time we have. Or maybe
we have one more question.
Okay, cool.
Okay.
So typically, computer science and cybersecurity are taught as like separate tracks that are not necessarily intertwining. Do you have any thoughts about how we can kind of approach this in higher education earlier in the, let's say the education of our future developers?
Golly, I have tons of opinions. I'm not an academic, so it's a little carping from the outside, and I don't understand the internal problems. I don't understand why security is not a core part of a computer science education 10 years ago, 15 years ago. I do not understand, and I'm sure the academics can tell us what the problems are, and funding and all of that stuff, but I don't understand. And why is it separate? No, it's part of basic computer science. You're going to be attacked. We know with certainty, absolute 100% certainty, that if you stick an endpoint, a routable address on the internet, it will get poked. Maybe not successfully because you've hardened it and taken whatever steps you've been able to take, but it will get poked with 100% certainty. Why is that a core piece of our understanding? That's one of the only things we know with 100% certainty. You put something on the internet, you're going to get whacked. Because we have sweeps going through the IP4 address space constantly. And it's just a matter of time before they get to your endpoint. Maybe it's 17 seconds. I saw that number trotted around a few years ago. And maybe it's 8 hours, but you will get poked. So, this is an obvious fact. I mean, is academia really that far? I'm sorry to go to you, but you folks are both working in academia. What the heck? I'm sorry. That's all I got to say. I want it desperately, and I'm going to put some money behind that because I'm going to go teach for what I get for 1 day of training at a university in order to make this happen. And at least I will be making that happen. Best I can do. And of course, I know some people. I know Quinnipiac University, not to poke one university over another. They have quite an extensive InfoSec program. So because I know Fred Scholl, who runs it, and so we talk about it from time to time. So there are some bright spots. There are. And James has one of the first PhDs in InfoSec ever given. So and when was that, James? I don't want to out you for your age, but it was, okay. I'm sorry. I shouldn't pick on you. All right.
Hey, Brooke,
Thank you very much.
Brooke,
Yes.
to the person asking the question, so if you're listening and watching, if you email info@forallsecure and we get enough response, we'll put one online for free. I'll teach what we teach at Carnegie Mellon, and we'll put together a free online one for everyone.
Yahoo!
Videos, and we'll provide the infrastructure to actually even test it using Mayhem. But we have to have enough response. So email info@forallsecure.com, do it now, and I'll put it together for you.
David, can I put that on my Twitter feed and on my LinkedIn feed?
You can.
Can
It's a
I out
post.
this whole thing?
We will do it if there is the demand.
All
I
right.
will do it personally.
Yahoo! All right. Thank you very much. You are very kind to listen to my ramblings for half an hour or more. I really appreciate it.